Welcome to this explainer. Okay, if you're tuning in today, there's a pretty good chance you are staring at a terminal screen that's just flashing red. You're dealing with broken code, and you're probably contemplating throwing your laptop straight out the window. Trust me, we have absolutely all been there. You integrate a powerful tool like the Headroom SDK to optimize your LLM costs and slash latency, but somewhere along the line, the whole engine just stalls out. Well, take a deep breath, right? Because today, we are setting a super energetic, systematic tone to squash these bugs once and for all. We're going to build a comprehensive triage protocol to get your Headroom implementation running flawlessly. So here is our roadmap for today. We'll start with installation and setup fixes, then move into proxy server connection issues. After that, we'll tackle tuning compression and latency, fixing provider-specific errors, and wrap it all up with advanced debugging and support. Let's just dive right in. All right, part one, installation and setup fixes. We're starting at the very foundation of your integration journey here. Because, before we can optimize even a single token, we need to get the SDK actually installed without your terminal yelling at you. Okay, let's look at this dreaded wall of text. You run a simple pip install and boom, suddenly you're hit with this. Runtime error, unsupported compiler, at least C++11 support is needed. It is a classic roadblock. See, Headroom relies on some pretty heavy under-the-hood performance optimizations that literally require modern C++ compilation. But hey, do not panic, it's actually a super easy fix once you isolate the cause. So here are the quick solutions to blast past those initial blockers. If you're building inside Docker, the secret sauce is all about layer management. You've got to make sure you install your build tools, run your pip install, and then remove those build tools all in a single Docker layer. That keeps your image size super clean and compact. Now, if you're running locally, just verify that your system has a C++11 compatible compiler actually installed before you try installing Headroom again. And if you cleared that hurdle, only to hit a module not found error, well, that's your cue to double-check your virtual environment. Make sure you haven't missed any optional dependencies required for your specific setup. Moving right along to part two, proxy server connection issues. So your SDK is installed, awesome. But that transition from setup to runtime, it can be pretty bumpy, especially if the Headroom proxy server itself stalls out or just flat out refuses to talk to your app. If you're desperately scanning your terminal output right now, and you spot this classic curl 7, failed to connect to localhost port 8787 error, yeah, that means your app is trying to route traffic through the Headroom proxy, but the proxy simply isn't listening. It's basically a textbook connection refusal. Now, there are really three main flavors of proxy errors, and understanding them lets you instantly categorize your pain point. First, if the proxy fails or just hangs the second you start it, that is a startup failure. You're likely looking at a port conflict or a bad config. Second, if you see that curl error we just talked about, that's connection refusal. The proxy probably isn't running at all. And third, if your requests work sometimes but occasionally fail with 502 or 503 errors, you're dealing with upstream or routing issues. That means Headroom is running, but it's really struggling to reach your AI provider. Pinpoint your symptom and boom, you found your diagnosis. All right, part three, tuning compression and latency. The crucial point here is that once the proxy is running smoothly, you actually want Headroom to do its job, right? It isn't just a pass-through. It's designed to compress context and save you money and time. But what happens when it doesn't? Picture this. You're checking your metrics. You pull up that token saved total stat, fully expecting a triumphant number, and you see a big fat 0. Honestly, it's a super frustrating mystery. You did all the work. You routed the traffic. So where are the savings? Let's solve this right now. There are a few common culprits behind this 0 savings mystery. First off, check your mode. If Headroom is set to audit, well, it's merely observing the traffic. It won't make any modifications, which means, you guessed it, 0 savings. Second, take a look at your payload. Are there actually tool outputs in your messages? Headroom specifically targets those. And furthermore, are those tool outputs large enough? Headroom intelligently ignores anything below a 200 token threshold, just because compressing tiny strings really isn't worth the compute overhead. Finally, consider your data itself. If you're sending highly unique data, raw code blocks, or dense script results, the engine might correctly determine that the data is just inherently incompressible without losing meaning. But let's look at the flip side of that. If your compression is way too aggressive, you're going to start seeing this symptom. Your LMM responses are suddenly missing crucial information that was definitely present in the original tool outputs. This data loss basically means Headroom crushed the context a bit too hard, and you need to dial back your compression settings to maintain the integrity of the prompt. And if things are just generally sluggish, like if your requests are taking significantly longer than expected, high latency is a distinct symptom of its own. This usually requires its own set of tuning adjustments. It might mean the proxy is overwhelmed, or maybe your cache configuration isn't optimized, which ends up forcing Headroom to reprocess data completely unnecessarily. Moving into Part 4, Fixing Provider-Specific Errors. As we continue our triage protocol, we absolutely have to handle external connections. Since Headroom sits right between your app and the AI provider, it naturally interacts a bit differently depending on whether you're talking to OpenAI, Anthropic, or someone else. It is actually fascinating how different providers handle the exact same root cause. Think about it. If your API key is missing, expired, or incorrect, OpenAI will explicitly tell you invalid API key. Anthropic, on the other hand, throws a slightly more generic authentication error. Knowing these provider-specific translations is huge because it proves that the fix is the exact same, even if the error text on your screen looks totally different. Now, there are a few other configuration quirks to watch out for. If you're seeing unknown model warnings, that's usually just a simple typo check. Just verify that your model name strings perfectly match what the provider expects. And here is a serious pro tip. If you're getting a validation error during your initial setup, temporarily swap to in-memory storage. This perfectly isolates the issue, letting you confirm whether the problem is your core configuration or your persistent storage backend. All right, on to Part 5, Advanced Debugging and Support. So, what happens when the quick fixes just don't work? When the table of common symptoms completely fails you? Well, that's when you need to bring out the heavy diagnostic machinery. Thankfully, Headroom provides some really incredible built-in tools for exactly this scenario, letting you peek right under the hood. First up, enable full logging. That way you can trace the exact raw data flow in and out of the proxy. Next, use the simulation feature. This is incredibly powerful. It lets you safely inspect how Headroom would transform your data before you actually run it in production. Finally, you can test transforms directly. This isolates specific logic blocks so you can see exactly where the compression or caching might be misbehaving. If all else fails, you need a strict step-by-step escalation path. Start with debug logging, then run your simulate function. After that, execute validate setup to catch any lingering config bugs. If you've done all three and you are still stuck, okay, it's time for step 4, filing an issue on the Headroom GitHub. But remember, a good developer helps maintainers help them. Always include your Headroom version, your Python version, your provider, the debug log output you just generated, and crucially, minimal reproduction code. I want to leave you with a bit of a provocative thought as we wrap up this explainer. When you encounter these errors, are you just frantically applying band-aids to get the terminal to turn green? Or are you using this triage protocol to build a truly resilient system? Look, every error we've covered today, from C++ compiler flags to zero-token saving mysteries, it's all a window into Headroom's underlying architecture. By understanding the why behind the bug, you don't just fix your code, you engineer a fundamentally faster, more cost-effective AI application. Keep exploring, stay curious, and as always, happy building.